So in problem number 9 here, we have a rational inequality. And remember, what you want to do there is solve the equation first to find your key numbers, and then you're going to use a chart with test values to find out when this inequality is true. So first thing that we want to do is bring the 3 over x over on the left-hand side. So we will have 5 over x plus 1 minus 3 over x. And then instead of greater than 0 here, we're going to solve the equation first. Find out when it equals 0 to get those key values. So we need an LCD between these, and our LCD is just the product of the two denominators, x times x plus 1. So let's now build up our fractions to the LCD. So what's missing in the denominator here is the x, so we're going to multiply by x over x. And then minus 3 over x. What's missing in the denominator here is the x plus 1. So we multiply by x plus 1 over x plus 1 equals 0. And then let's see here, 5 times x is 5x minus 3 times x plus 1. And then both of those will be over the LCD of x plus 1. Let's go ahead and multiply the negative 3 in here, distribute that in. So this will be 5x, negative 3 times x minus 3x, negative 3 times 1 minus 3 over our LCD of x plus 1. And equals 0. And then if we simplify here, 5x minus 3x is 2x, minus 3 in the numerator, and x plus 1 in the denominator. And then remember the key numbers you get from setting both numerator and denominator equal to 0. So 2x minus 3 equals 0. Bring the 3 over as a positive, so add 3 to both sides. 2x equals 3. Divide both sides by 2. X equals 3 halves. And then set your denominator equals 0. So x plus 1 is equal to 0 either when x is 0 or when x plus 1 is equal to 0, which means that x is negative 1. So your key numbers are negative 1, 0, and 3 halves. So here's our number line. I've marked negative 1, 0, and 3 halves with open circles because this is a strict inequality. So the places where equals 0 are not going to be part of the solution. And so from that, our test intervals are this piece over here, less than negative 1, so that would be negative infinity to negative 1. You've got this interval in here between negative 1 and 0. The interval between 0 and 3 halves here. And then this last interval from 3 halves up to infinity. So those are your test intervals. And we'll transfer those down to the chart here. So negative infinity to negative 1. Negative 1 to 0. 0 to 3 halves. And 3 halves to infinity. And then we pick a test value inside each interval. So in this interval here, why don't we pick negative 2? In the interval here between negative 1 and 0, how about negative 0.5, negative 1 half? Between 0 and 3 halves in this interval, let's pick 1 for our test value. And then from 3/2 to infinity over here, let's pick 2. So just pick the easiest number. And then we're going to plug that into the 2x minus 3xx plus 1, which was the left-hand side simplified. And we're going to see if that is positive or negative. So we want to know when that is greater than 0. So the inequality would be greater than. We set it equal to find the key numbers. So we'll plug our -2 in all 3 places. So we've got 2 times -2 plus 3 over -2 times -2 plus 1 would be -1. So that's going to be what? -4 plus 3, -1 over 2. And -1/2 is less than 0. And we want greater than 0. So we're going to reject that interval. Plug a -0.5 in all 3 places. So 2 times -0.5 plus 3 over -0.5. And then -0.5 plus 1 would be times 0.5. So in our numerator, that would be -1 plus 3, 2. In the denominator, -0.25. So that's dividing by -1/4. That's multiplying by 4. So that's going to be what? -8. Yep, -8. Oh, wait a minute. Got a sign error here. That should be a minus, and this should be a minus. I don't think that's going to change things in the first interval. So minus, that'd be -4 minus 3, -7/2 is still less than 0, reject. 2 times -0.5, -1 minus 3, -4 on top. There we go. So -4 divided by 0.25, that's going to actually be positive 16. That's greater than 0. So that interval we are going to keep. That's part of the solution. And then plug in 1 here, here, and here. So 2 times 1 minus 3 over 1 times 1 plus 1, 1 times 2. So that'll be what? 2 minus 3, -1 over 2, -1/2. That is less than 0. So we reject that interval. It's not in the solution. And then x equals 2. Again, plug it in for x. So 2 times 2 minus 3 over 2 times 2 plus 1. So 2 times 3. So 4 minus 3, 1/6. And 1/6 is greater than 0, so we keep that interval. So then our solution is going to be the interval -1 to 0. Keep that one. And then we also keep the 3/2 to infinity. So union 3/2 to infinity. And then if we want to graph that solution, we would just darken it here and here. So that would be the graph of our solution. So you solve the equality first and then use your test points.